What's up, everybody? Good morning. Welcome back to another live stream, weekend live stream. So we usually do live streams every Wednesday related to SAT material. Sorry, I'm just doing a quick audio check here and making sure we're good to go. Yeah, we are good to go. We are good to go. So anyways, we usually do the live streams every Wednesday where we tackle SAT material. I'm in the process of doing something with this phenomenal software, a phenomenal math program called ALEKS. And a couple weeks ago, I set out to conquer all 630 topics of the pre-algebra pie. So the way ALEKS works is there's pre-algebra, algebra, geometry. It has the entire curriculum in this amazing interface. And what I want to do is I want to go through and provide my own video explanations with my own style for every single topic that exists. And I'm starting off with pre-algebra because that is something that I teach for my 6th graders. And my initial aim was to get through all 630 topics, or try to get through all of them in one day. That proved not to happen. We were having some difficulties last time getting ALEKS to respond in a timely fashion. There was something going on. So I only got through a paltry 47 topics out of 630, but that's okay. I started off, and today we're going to continue. Hopefully I'll get in about 2 hours worth of ALEKS. So let's see how many problems we solve. I'm estimating about 80, but let's go for it and give it a shot. So right here, ALEKS, we are at the pie, and we've got 47 topics out of 630, and we're going to keep going by clicking continue my path. And we're just following along wherever it takes us. All right, so starting with ordering integers. Here we go. So now we're deciding which one's bigger and smaller. Now remember, when we have integers, we want to think about a number line. And we're really looking at the numbers farthest on the left, to the left on this number line, are going to be the smallest. So where do these numbers fall? Like, let's look at -6, for example. -6 would be 6 away from 0, okay? -12 would be 12 away from 0, but farther to the left, right? The zeros extend in this direction, just like the positives extend upwards in this direction. Maybe we'd have our 1 value right here. We'd have 3 right here, maybe 2 right here, right? And then that -2 value would be somewhere around here. And now we can do a quick comparison. Anything to the left is going to be the smallest. So you might think -12 would be bigger than -6. It's in fact the opposite. -12 is farther down the line, down the number line, than -6. It's a smaller quantity. Therefore, -12 is less than -6. 3, of course, is greater than 1. And finally, 2. Once again, 2 is farther to the right than -2. 2 is greater than -2. But any positive number is going to be greater than a negative number. Alright, cool. I'm going to do these next two really quickly. That guy, and 0, believe it or not, is greater than all negative numbers as well. And let's do the next one. That guy, and that guy. Boom. Done. Alright. Out of sight. Topic number 1 in the bank. Let's go to the next one. Multiplying a decimal less than 1 by a whole number. All right, we multiply by decimals with whole numbers. We want to do it just like normal multiplication, right? What's 5 times 7? It's 35. But then we look and we see how many numbers are to the right of the decimal, and all the numbers here. And here we only have one number, one digit to the right of the decimals in both of these numbers. Therefore, we move the decimal 1 spot to the left. And the final answer is 3.5. Boom. All right, let's knock out the next 2 of these. This would be 0.86, and that's just doubling 0.43. And this would be 0.14. All right, next one in going down is 4 equals v divided by 2. So now we're solving an equation. 4 equals v divided by 2. A lot of times when we write division problems, when we're solving equations, we don't really use the division sign much. Instead, we convert it to a fraction. It's much easier. So this is really v divided by 2. It's the same thing, v over 2. Now, how do we remove that 2? Basically, how do we isolate v? Well, we have to get rid of that 2. V is dividing 2. What's the opposite of dividing 2? We're doing an inverse operation, which is multiplying by 2. We multiply, but we multiply both sides by 2. Multiplying by 2 is the opposite of dividing by 2. Therefore, these guys cancel out, because 2 and then divided by 2 is just 1. 1 times v is just v. And then v equals 8. And you could even plug 8 into v here and see that it actually works, because 8 divided by 2 is 4. All right. Let's keep rolling. I'm going to do these ones quickly. This one would be 25. And the next one would be 3. Wow, they love it. They love it. All right, let's keep rolling. Equivalent equivalent fractions. Here's how you solve something like this, right? We've got a blank spot up here. Now really we can call that x, okay? And we've got x over 24 equals 5 over 8. Now one nice thing here, now if we need to, we could always cross multiply and solve, but they're giving us nice fractions here that are, these numbers are always going to be multiples of these numbers. That's how they're doing it. If that doesn't work, you can cross multiply, but check it out. Can we get from 8 to 24 via multiplication? We can. And it's just 8 times 3. So we're multiplying by 3 to get to 24. Well, if we're multiplying the top by a certain number to get here, we have to, or the bottom by a certain number, we have to multiply the top by that same number, because we can, if these are equivalent, it has to be the same path for both top and bottom. Therefore, to multiply that 5 by 3, it would take us to 15. And now just to show you, if you wanted to cross multiply, this is how you would use cross multiplication. We cross multiply becomes 8 times x equals 5 times 24, which is 120. Right? And then we want to isolate x, so we divide both sides by 8, opposite of multiplying. And we get x equals, same thing, 15. 15, and done. Now let's do the next one. I'm going to do it quickly. This is 24. And this one is 35. All right, continue my path. Cool, cool. Place value. Place value. All right, give the digits in the thousands place and the ones place. Thousands place is going to be right here, right? Ones place is here, tens, hundreds, and thousands. So thousands place is going to be 7. Ones place is going to be 4. Alright, and this guy, same thing, 9, and the 10 spot is that 7. Boom. Decimal subtraction. 99.53 minus 6.47. First of all, we got to get our setup nice. So our setup, don't forget, it's all about the dot. We got to line up those dots very precisely. That's when we make mistakes, is when this isn't precisely lined up. Now look how nice that is. We got the subtraction. Now this is straight up subtraction. We just remember that that dot stays in place, is going to come down here. Can't do 3 minus 7, so we're going to borrow from that 5, make it a 4. 13 minus 7 is 6. 4 minus 4, 0. 9 minus 6, 3. And then 9 minus nothing is 9. And that's it. Don't let that decimal trip you up. It's just like any other subtraction problem. So this is 93.06. Boom. Moving on. This one I'm going to have to, I can't do it in my head, I don't think. 37.28 minus 2.65. Subtract 3, 6, 12, 6, 4, 3. 34.63. 34.63. Last but not least, 77.22 minus 43.3. There's no digit here. I'm going to add a 0. And then we go 2, 6, 12, 9.33. So this is 33.92. All right. Breathtaking. Baller. All right, multiplying a decimal by a whole number. So far, Alex is moving really smoothly. This is great. Multiplying a decimal by a whole number is just like multiplying any two other numbers together. So I'm going to set it up. We just got to remember that since there's one number to the right of the decimal, we got to put the decimal place one spot to the left. So there's also going to be one number down here to the right. So 4 times 8, 32. Carry the 3. 4 times 5 is 20, plus 3 is 23. Carry another 2. 4 times 5 is 20, plus 2 is 22. And we got one decimal, so the decimal goes right here. 223.2. 223.2. Let me just make sure mentally. 3. Yeah, that's correct. All right, next one I'm going to try and do it completely mentally, just for fun. So let's see, 21. Oh, this is hard. I can do it, though. Think. 21 plus 4.2 is 25.2. 25.55. Let's see if that's right. I'm going to double check because I'm not sure. 3.65. 35, 3, 42, 45, 4, 21, 25. Yeah, I think it's right. Yes. All right, last one. This one is 10, 12.95. 12.95. Come on, come on, come on. Yes. All right, that's pretty good. Let's keep going. Next question. See if we got any comments going here. Is there anybody? No. All right. So multiplicative property of equality. So we got 78 equals 6u. Here's the deal. We're again solving for u, variable isolation. What's the 6 doing to the u? It's multiplying. Therefore, we want to do the opposite of that, which is divide. Divide both sides by 6. Must be a balance. 78 divided by 6 is 13. Therefore, u equals 13. All right, this one I'm going to do quickly. And this next one I'm going to do fast as well. Just multiply by 2. Shoot that 2 over like that. Got 92. All right, next one. Introduction to exponents. Sweet. All right, cool. I love exponents. And let's get it going. 4 to the 3rd power. Remember, that little 3 up here, it's telling us we have a multiplication problem, but it's telling us how many 4s are multiplying against each other. So that 3 means we've got a 4 times 4 times 4. 4 times 4 is 16. Times 4 again is 64. And that's that. All right, next one I'm going to do in my head. That's 12 times 12, 144. 2 12s multiplying each other. And the last one is 2 to the 5th power, which is 32. I have that memorized. All right, cool. Next topic. Writing expressions using exponents. And now we're going the other way, which is really cool. So let's check it out. 3 times 3 times 3 times 3 times 3. What did I say that little number is up top? It's telling us how many 3s are multiplying each other. Well, we can count 5 right there. So this is just 3 to the 5th. 3 to the 5th. Boom. Next question. How many 9s? 1, 2, 3, 4, 5, 6. So it's 9 to the... Whoops. Shoot. Oh, shoot. 9 to the 6th power. Yes. Last question. 8 times 8. That's just 2 8s. That's 8 squared. All right. Excellent. Estimating a product. Let's see what we got here. So why do we estimate? Why do we estimate? We estimate to make life easy for ourselves, and we want to get nice numbers that we can do quickly and mentally, especially if somebody's asking us something on the fly. So look what they're kind of coaching us here. We got 5 times 45, and we could either estimate up or down, and we're choosing a nice number with a 0 at the end to make life easy, because 5 times 40 is similar to 5 times 4. 5 times 4 is 20. 5 times 40, therefore we add 1 0, and it's 200. 5 times 50 is like 5 times 5, which is 25, plus 1 0 is 250. And Diane, now what are we saying? Diane and Aldo are trying to estimate this. Diane says 200. Aldo says 250. Which one's closer? Well, they're actually equally close in this case. Now, how do we know that? Well, this is a weird case where 40 is just as close to 45 as 50 is. Right? They're both 5 away. So we can say that these estimates in this case are actually equally close. The correct answer, if you multiply it out, is 225. All right. Let's move on to the next one. So I'm going to do this mentally. That's 5,400. This one's 6,300. And we can tell that since this is closer to 700 than 600, Manuel's estimate is going to be closer. And lastly, let's look at this last problem here. 6 times 50 is 300. 6 times 60 is 360. And it's, again, going to be right in the middle. Let's move on. Integer addition. So now we are adding and subtracting integers, both positive and negative. So let's give it a shot here. First, we got a -1 plus a -5, right? And what does that give us? Well, we got two negatives being added to each other. The way you want to think about it is when they're on the same team, we're just going, they're adding. They're just getting bigger and bigger, or more. Or the numbers are growing, at least in magnitude or absolute value. So -1 plus a -5, same team. It's just like 1 plus 5, which is 6, but it's -6 because they're same team. They're getting more negative. When it's different teams here, like we got 6 and we got a -3, a positive and negative. Now this is a subtraction problem. We subtract the smaller quantity, which is 3, from the larger, which is 6, and we get 3. But then we determine, well, what's the sign? Is it positive or negative? It's positive because the positive value is the winner. The positive value dominates here. It's larger than the negative, so we get a +3. So here we have a -6. Here we have a +3. All right, I'm going to do these next ones quickly. -5 is -5, more negative plus a negative. We're adding -10. These guys are opposites. They cancel out to 0. Right? A -6 plus 6 is just like 6 minus 6. Last but not least, let's take a look at this guy. We got 1 plus -3, opposite, so it's subtraction. 3 minus 1 is 2, but the negatives dominate, so it's a -2. Same team, so it gets bigger, and it becomes more negative, and we add them, we get a -4. All right, we're blazing today. This is really good. Here we go, next topic. Boom, integer subtraction, problem type 1. So now we got 2 minus 5 on top and a -4 minus 5 on the bottom. Now the best way to think about this is, again, it's just like the last topic where we are adding and subtracting positive and negative integers. So think about it like this. This is really a minus sign is just like a plus negative. 2 is being added to a -5. So they're not on the same team. We look at it as a subtraction problem. It's really just like 5 minus 2, which is 3. But since the negative number dominated, this final answer is going to be -3. So 2 plus -5 is -3. I'm going to do the same thing down here. I'm going to take that negative and turn it into a plus minus. Now look what plus negative. Now look what's happening. We got two negative numbers, same team. Therefore, we add them straight up and we get a 9. But remember, they were negative, so we're getting a negative as our answer. So this is the top one, we're going to get -3, and the bottom one we are going to get -9. And that is that. Excellent. All right, let's move on to the next question. Here we go, -7. Oops, -7 minus 5, 4 minus 8. So it's the same idea, right? These guys are both negative, so we're getting more negative and we're becoming -12. Different teams, and we subtract them, but the negative dominates, so we get a -4. All right, and last but not least, slowing down a little bit. I can feel ALEKS slowing down a little bit than when we first started. Maybe that's what happens when after you solve a few topics, or a number of topics. I don't know, but it's all good. And that one's -2, right? Because we got two negatives combining. Fantastic. All right, let's keep it going. A learning streak of 28. And I think that learning streak continues so long as I don't get anything wrong. All right, let's see if we can keep it going the entire time. Multiplication of a decimal by a power of 10. All right, these are great because what you want to think about here is whenever you multiply by a power of 10, look at the number of zeros. That's just telling you the amount of times we're moving a decimal to the right. Whoops. We're multiplying this. I use a dot for multiplication instead of an X. So we're going to move this decimal. Since there's 2 zeros, we're going to move the decimal once, twice. And so our final answer is 750. So we say 750. All right. Next two, I'm going to blast through quickly. All right. We just move it one spot because it's 1 0. And last but not least, we're going to move it 2 spots. So it's 814.9, right? Cool. All right. Integer multiplication and division. Let's get it going. -48 divided by 6. The rules with negatives and positives, I'm going to write it like this. The rules with negatives and positives when we're talking about division and multiplication is the negative always dominates. The negative is like an infection. So if you got a negative times a positive or negative divided by a positive, the negative infects and the final result is going to be negative. So in this case, we got a -48 divided by 6. We do the division just like if they were both positive, and that's 8. But that negative infects this quantity and we get a -8. Now, the only way to cure the infection, to get rid of a negative, is if we have another negative come and cancel it out. So that's how you want to think about it. It's an infection that can only be cured by another negative. And that is happening in the second question. So we got a negative number times a negative number, right? Both of these guys multiplying. So the negatives cancel each other out. -4 times -8 becomes a positive 32. So here's -8 and positive 32. All right, let's go to the next problem. Now these ones I'm going to race through a little bit more quickly, as I've now explained it. This one is going to be -14. Oh no, I didn't answer the other one. Oh good, gave me a second chance. I forgot. -14 and -5. Cool. Done. See, you see it slowing down, right? This is what happened on Martin Luther King Day when I did a bunch of these. It starts getting slower as you move on. I don't know why. This is a -5. This is a positive 10. Right? Negatives cancel out. Negatives remain. All right. Excellent. Let's keep it going. Learning streaks are fun. Decimal subtraction advanced. I wonder, maybe this is 3 digits or 3 numbers? No, I don't know. Okay, so again, we want to line these up, and it's all about the dot, right? And every number has a dot. It just may not be visible. So if we line it up nicely, we're going to be good to go. 49.9 minus 48. You see how the dots are lined up like that? 5, 1. But we don't have a digit here. It's short a digit. Well, remember, there's an infinite amount of zeros that go to the right after the decimal. So we can just throw on a 0 there. Because it's there, we just didn't write it. And now we can subtract this no problem. 0 can't subtract 1, so we're going to borrow a 1 from here, and that makes it 10 minus 1 is 9, 8 minus 5 is 3, dot 9 minus 8 is 1, 4 minus 4 is nothing, so our answer is 1.39. 1.39. All right. I'm just going to try and do the next two mentally if I can. Let's see how this works here. 92 minus 0.2 minus 6 is just 86.6, right? I mean 86.2, excuse me. And last but not least, why? See, why does it slow down? That's really confusing to me. All right, let's give this last one a shot here. All right, 5.9 ooh, I can't do that mental. Oh, maybe I can. It's 0.031. It's 2.131, right? No. 2.031. All right, because that will make it 5, and that will jump it to the 0.9. Let's give it a shot. Hope it's not wrong. Come on. Yes. All right, sweet. Let's keep it going. Evaluating a formula. All right, evaluating formula. Oh, sweet. This is slope. This is slope-intercept form, at least what I saw in the example, which is how that's the formula for creating a line, but this is a different formula. So we're doing all sorts of different formulas. Evaluate. Use the equation to find A. If L equals 8, W equals 7. So what they are saying is we are replacing these variables with the numbers that they have been assigned. But don't think that we do an 8 and a 7, it becomes A equals 87. When variables are written like this, they're multiplying each other. So it's really L times W. And now we're just saying, well, L equals 8 and W equals 7. And so we just continue to multiply them. And what's 8 times 7? That is 56. Boom. All right. Excellent. Let's go to the next one. Do this one a little bit more, next two a little bit more quickly. W is 52, M times A is 15, right? So this is 15. 52 minus 15 is 37. Let's see. Yes. All right, last one. A plus B plus C is 6 plus 16, 22, plus 13 is 32, 35. Done. Cool. Continue. All right, next question. Rounding to hundreds or thousands. Let's see. You notice this program is slowing down. All right. Round 7,483 to the nearest thousand. So we're rounding this spot. The way I love to explain these problems is you want to think about, if we're rounding to the nearest thousand, it means we can either go up to 8,000 or go down to 7,000. And you look at this and it's like, which one is it closer to? 7,000 or 8,000? I'd say it's closer to 7,000 because it's 483 away from 7,000. It's 517 away from 8,000. Therefore, we're going to go with 7,000. We round it down. The other way to think about it is we look at the hundred spot, right? If it's 5 or greater, we jump up to 8,000. If it's 4 or less, like it is here, we jump down to 7,000. So this goes down to 0, or all of these numbers go down to 0, and we got 7,000. All right, cool. And I'll do the next two quickly, but I will explain them. All right, once again, to the nearest hundred, so that spot is closer to 2,400, closer to 2,400 than 2,300. And last but not least, the nearest 100, 3200. Done. Cool. All right, let's keep it rolling. Let's keep it rolling. Product of a unit fraction and a whole number. Come on. All right. Here we go. What is 1/6 of 36? So the way we set this up is we say 1/6 of is always just 1/6 times. That's what the of means. So we're doing 1/6 times 6. But it's a little weird to multiply a fraction by a whole number. So we turn every whole number into a fraction like this. Okay. Every whole number is just a number over 1. And then we can multiply across and multiply across on the top and bottom. Now, if you want, before you do that, you can also cross-simplify. Simplify across the fraction and within the fraction, only with multiplication. Like I see a 6 here and a 6 here. So I can simultaneously divide this 6 and this 6 by 6 and reduce it to 1. Reduce it to 1. And then it's just 1 times 1, which is 1, over 1 times 1, which is 1, which equals 1, right? 1 over 1 is just 1. Oh, wait. What did I do? I did the wrong problem here. Oh, I almost entered the wrong number. Let us back it up. What is 1/6 of 36? So it's the same idea. 1/6 times 36 over 1. So excuse me. So now we follow the process of multiplying across on the top, multiplying across on the bottom when we do multiplication. But we can take one step ahead of time to see if we can simplify. And the way we simplify is we look at numbers on the bottom and on the top and see if we can have some common factors that we can divide by. And 36 and 6 have common factors. We can divide this by by 6, and divide this by 6. So 36 divided by 6 is 6. 6 divided by 6 is 1. And now we multiply across with these new numbers. 1 times 6 equals 6. 1 times 1 equals 1, which is simply 6. And that is correct. Let's keep going. All right, 1/4 of 20, same idea. I'm going to do this quickly. It's just 1/4 of 20 is 5. And next. Come on, ALEKS. Sweet. 1/7 of 56 is just 8. It's basically 56 divided by 7. Let's see. Let's see. Is it right? Yeah. All right, cool. We got it. Let's keep it rolling. We'll check. I'm not even sure exactly where I'm at topics-wise, but we'll check later. And maybe I'll do another 5 or 10 topics. I'm hoping to keep going until around 11:15. Hopefully I have the stamina. Got a long day ahead of me too. Decimal place value, tenths and hundredths. Here we go. Give the digits in the ones place and the hundredths place. So ones place is right here, right? This is tens. This is ones. So ones is just 8. Hundredths place, now we go to the right of the decimal. The first spot over is the tenths place. The next spot over is the hundredths place, all right? So in the hundredths place up here we have 9. All right, cool. Next, let's do these ones quickly, hopefully. 57.34, the 10th spot is 3, 100th spot is 4. Done. Now don't forget, if that's a tens spot, it would be 5, but it's a 10th spot, which is the 3. I really like doing these problems and working through ALEKS myself, because my students at the school where I teach, they have to work on ALEKS. I'm always helping them, and so I'm familiar from that perspective, but this is a new insight as far as I think I can understand a bit better their frustrations when they get through points that they're having difficulty with and so on and so forth. So I think this is really cool. All right, let's keep going. Let's see what's up next. I am excited. Today I'm gonna be purchasing some new audio equipment, which I'm very excited about. If you guys haven't seen yet, I have a bunch of math music videos. You should definitely check them out. But I'm going to really get back to my roots in music production and start making all my own beats from scratch without loops or anything. So I'm super stoked. Okay, here we go. Plotting a point in quadrant 1. So we're plotting the point 6, 0. Now the way you want to think about plotting is you look at this first term. That first term is the x coordinate, okay? And x matches up with this axis right here. This is my y coordinate, which matches up with this coordinate here. So when we want to plot a point, we want to think we're starting at 0, 0, which is the origin. And first, the x coordinate tells us how far we go on the x-axis. So we go 6, so we find the 6 point, and it's right here. All right. And then this value tells us how much we go up along the y-axis, right? So we've kind of gone to the right by 6, but it's 0, so we don't go anywhere. So our point is actually right here, and that is 6, 0. It's right on the x-axis. I'll do one more example to make this clear. If you haven't used a graph yet, it can be a little confusing. Coordinate plane graph. We use coordinate planes all the time for actual maps and technically GPS systems, although they're really quite 3D now. But it's always these types of planes. So again, plot point 1, 2, right? So on the x-axis, we're going out by 1, according to this, right? And then on the y-axis, we go up to 1, 2, and we are right. Boom, right there. All right, sweet. And our final problem, plotting a point in quadrant 1. Let's see what we get. We got 4, 3. So we go out for 1, 2, 3, 4, and up 3. 1, 2, 3, boom. All right, while this is taking so long to load, I'm going to load up my Instagram and do a little simultaneous live stream from there as well. Live. Let's put it over here. I think people can see me. Yes. Cool. What's up, Instagram? Today I'm continuing my live stream on my YouTube channel where I'm solving a bunch of ALEKS problems. So you're just going to be seeing me and you're going to be watching me and hearing the math problems that I'm solving. You won't be able to see the math problems that I'm solving because you're going to have to tune into my YouTube channel to actually watch that. Yeah, thank you, Tasteless Sugar, for that. And yeah, so you just go to my YouTube channel and you can actually watch me solve the math problems live. And what I'm doing is I'm going through problems from ALEKS. So go to YouTube, search for Scalar Learning, and you can check it out there. All right, now I'm going to continue here. So let's see with the next topic we are working on. There's word problems with addition or subtraction. What's up, Thug Geek? Thank you for joining. I'm about to get onto a new problem, so you can kind of listen and see how it goes. But like I said, jump on my YouTube channel if you actually want to see the problems. Here we go. Word problem with addition or subtraction. So I'm going to read it out loud. And on Instagram, you guys can try along and see if you can solve it just by hearing it. So we say, this morning, Ahmed's car had 26.29 gallons of fuel. Now 1.7 gallons are left. How much fuel did Ahmed use? So he had 26.29. And now there's only 1.7 left. So the question is, what type of problem is this? Is it addition or subtraction? Well, think about it. We're trying to calculate how much he used. It's essentially the difference between what he started with and 1.7. So this is a subtraction problem, so we're going to subtract. Once we made that determination, now we follow the steps that we learned before. Again, we don't have anything here. We want to match up all the digits, so I'm going to just add a 0. And now we're good to go. 9 minus 0 is simply 9. We can't do 2 minus 7, so we're going to borrow 1 from the 6. Now we got 12 minus 7 is 5. Don't forget the dot. The dots must be lined up. Then 5 minus 1 is 4, and 2 minus nothing is 2, and we got 24.59. All right, cool. Let's clear the board. Let's keep going. Now we have same thing. Bowl contained 38.3 grams of salt. Then Linda poured another 37.49. So this is addition, right? We're adding two quantities. It's kind of spelled out for us in the problem. So 37.49 plus 38.3. I'm going to add a 0 to match it up. This is addition. 0 plus 9 is 9. 3 plus 4 is 7. Don't forget that dot. 8 plus 7 is 15. Carry the 1. 3 plus 3 plus 1 is 7. 75.79. And we are, let's see if it works. Done. All right, cool. Let's move on to the next problem. All right, cool. The price of an item has been reduced. Reduced tells me right off the bat. This is going to, oh, actually, no. I was about to speak too soon. Has been reduced by 4.7, and the new price is 55.24. To get back to the original price, since we had to subtract this, we need to add this back on to get to the original price. So 55.24 plus 4.47. Make sure my numbers are good. Just double checking. 1, 7, 9, and 5. So 59.71, and that looks good. 59.71. All right. Cool. For you guys on Instagram and you're watching along right now, you're just hearing me solve math problems. If you actually want to see me solve the math problems and work through them, go to my YouTube channel. Go to YouTube, search for Scalar Learning, and you can jump on the live stream. And I'm live streaming right now. And it'll be a little bit more fun to actually see what I'm doing. And we are working through ALEKS, which is a math program that is used in a lot of schools as a curriculum supplement. And I'm just going through everything in pre-algebra. So I'm essentially teaching an entire year's worth of pre-algebra over, I think it'll be probably 12 or 16 hours, somewhere in that zone. Okay, reading a point in quadrant 1. Let's see what we got. Okay, write an ordered pair for the location of the park. So what we're trying to do is, here's the park, right? And we need to decipher what this XY coordinate is. Now, remember, to figure that out, the park, we need to figure out for the X value, well, how far out is it on the X axis? Well, it's lined up with what value? It's lined up with the 6 value. Therefore, this X coordinate for the park is 6. Well, what about the Y? The Y is lined up with the 4 on the Y axis. Therefore, the coordinate is 6, 4. All right, sweet. Next. Question number 2. All right, now post office. Post office is right here, right? How far out did we go on the x-axis? We didn't go out at all. So that first point is 0. How far did we go on the y-axis? We went up 1, 2. Therefore, the y value is 2. And that's that. Done. Come on. All right, sweet. Let's keep going. Next. Come on. All right, reading a point, same thing. Order pair of the school. We've gone out 3, so 3 on the x-axis. Whoops. 3 on the x-axis. We've gone up 4 on the y-axis for the school, right? And that's that. 3, 4. It's so important to be able to read a graph. It's kind of something that you'll have to do forever in mathematics, in calculus, pre-calculus, anything and everything. All right, integer addition, problem type 2. Here we go. All right, negative 40 plus 48. Remember, first we want to determine when we're talking about addition, are these guys on the same team or different? They're on different teams. One's negative, one's positive. Therefore, it's a subtraction problem. So what is 48 minus 40? It's just 8, right? But then which side wins, positive or negative? The positive side wins. Positive's bigger, positive dominates, so it's a positive 8. What about this guy down here? A negative 48 plus a negative 42. They're on the same team. Therefore, this is an addition problem. It's 48 plus 42, which is 90. And since they were both negative, the final answer is negative. So negative 90. So we got 8 up top, negative 90 down below. All right, let's check over here. Okay, let's see. Let's see what we got. Hey, thank you for jumping on, Michael Saliba. Make sure to jump on the live stream on YouTube if you want to see me actually solve these problems live and see what I'm doing. All right, next question here. Another integer problem. Next two I'm going to do quickly and I'm going to just do mentally. All right, negative 45 plus negative 30 is negative 75, right? Two negatives make another negative. 41 plus negative 43 is negative 2. That's a subtraction problem. Negative dominates, and we get a negative 2. Let's see. Awesome. All right, keep going. All right, just waiting for this to load. It's going to load. Cool. Negative 55 plus negative 32 is negative 87. Negative 24 plus positive 48 is positive 23, right? It's a subtraction problem. 23. Make sure my math is correct. I think it's good. And all right, so I see you have just jumped on to my live stream here on Instagram. You're saying you're not understanding. What I'm doing right now is I'm solving a math curriculum by a company called ALEKS. And if you actually want to see the problems and understand what I'm doing, what you want to do is you want to go to my YouTube channel. So go to YouTube and search for Scalar Learning, and you can jump on the live stream. And there you can actually see the problems, not only just hear them. And you're going to watch me go through the entire pre-algebra curriculum of this program. Or I'm going to do as much as I can today, probably go for another 45 minutes or an hour, and then I'll continue on over the next few weeks to tackle the entire thing. All right. Identifying solutions to a one-step linear equation. So if you are unfamiliar with linear equations, it's literally an equation that determines a line, or what a straight line looks like when it's graphed on a coordinate plane. Here we go. For each value of u, determine whether it is a solution to 5u equals 20. All you have to do here, all right, is plug u in for u over here, and we can determine if it's a solution. Actually, the other way to do it, an easier way to do it, is just solve for u, because it only has one solution in this case. 5 is multiplying the u, so to get rid of the 5 and isolate u, we do the opposite. We divide both sides by 5, and we get u equals 20 divided by 5, which is 4. So the only one of these, so 5, no, it's not a solution. 1, no, it's not a solution. 6, it's not a solution. 4, yes, it is. And that is that. We are done. So let's math. You're asking why you can't see the screen. The screen is only available, can only be seen on my YouTube live stream. So what you want to do is go to YouTube. Yeah, thank you, Michael Sleeba. Go to YouTube and search for Scalar Learning. The same name as this Instagram account. You'll see the live stream happening right now there. Click on that, and on the YouTube live stream at Scalar Learning, you'll be able to see all the problems that I'm solving. I agree. I just don't have the same interface on my phone to be able to show what's going on. Like, for example, I can kind of show it to you here, but everything is up on the screen, if you can kind of see right there, right? I just have to kind of keep it here. But my goal is My goal is for you to listen, and if you want to actually watch, go to YouTube. You can check it out there. All right, I'm going to keep moving on to the next problem. Identifying solutions to a one-step linear equation. And these two I'm going to go through much more quickly. All right, so first of all, what's the solution to 18 equals 3y? Well, the solution is 6, right? 3 times 6 equals 18. So none of these are solutions, right? The only one that would be a solution would be 6. They give 8, 15, 5, 9. All are no good. So I'm saying no to everything. And then we're going to look at the last one for identifying solutions to a one-step linear equation. Let's see what we got. You know, once again, this program is slowing down a little bit, which does happen. So it says 9 equals u divided by 2. So what divided by 2? We could basically multiply both sides by 2, and we get u equals 18. So only 18 is a solution to this linear equation. None of these other ones. All right. Hey, what's up? I see Orlando is on the live stream over here. What's up, Orlando? Thank you for joining. I think you watched my my last live stream where I was tackling topics from ALEKS, and hopefully you remember it was glitching. Not glitching per se, but it was slowing down. Now it's the same thing is happening today. It's going really slow. Started off super fast, so I don't know what's going on there with the program. But we're going to make our way through for another hour. All right, guys. Thank you for joining. All you Instagram followers, thank you so much for checking this out. Again, if you really want to see the problems, go to my YouTube channel. Go to YouTube. Search for Scalar Learning. Cool. We're just talking now about even and odd numbers. So what are even numbers? What are odd numbers? Even numbers are any numbers that end in an even number. Doesn't matter if it has an odd number in it. It just has to end in an even number. Even numbers ending in an even number would end in 0, 0, 2, 4, 6, and 8. Okay, and all of these are actually even numbers. So 86 even, 780 even, 72 even. These two are odd because they don't end in these. They end in an odd number, and that's how we break it down. Hey, thank you for saying that. I'm so glad you love the page and love the videos. I'm glad they're helpful to you. And Turkçe biliyor a little bit. All right, let's keep it going. Now these next two I'm just going to blast through really quickly. 10, 17. I'm trying to figure out how long. I mean, literally, you see each one of these problems is taking 20, 30 seconds to load. It's kind of frustrating. Yeah, so I got somebody from Turkey on the live stream, so I'll say other things I remember. Merhaba. I remember Seni seviyorum, right? I remember, what else? Oh, there we go. I forgot to click next. I remember, hey, what's up? I remember, oh, wait, how did you say? I can't, I'm trying to remember how to say, how can I have the bill? All right, here we go. I'm going to blast through these problems. Odd, because I end in odd number. Odd, even, odd. Boom, done. İyi akşamlar, right? Is that good night? I think. Günaydın is good morning. I learned Turkish when I lived in Turkey. I lived in Istanbul for a summer, and then I went back. I've been to Turkey many, many times. Even, Odd, odd, even, even. All right, we're done here. Somebody's asking about linear algebra. I actually don't have any courses on linear algebra, but that's something that I do want to tackle eventually with some of my video and curriculum material, but I haven't yet. Yeah, I lived right by Badat Juddasi. Or my girlfriend at the time did, not me. Okay, word problem with multiplication of a decimal. Here we go. Here we go. So Charlie bought 6 boxes of chocolates. Let's see how this works. All right, cool. Jane works 7.8 hours each of the last 4 days. How many hours did she work in all? Well, 7.8 hours each day for 4 days. So what's the multiplication problem? It's 4 times 7.8, right? How do we multiply decimals? It's the same as a regular number. 4 times 8 is 32. Carry the 3. 4 times 7 is 28. Plus 3 is 31. But then how many numbers to the right of the decimal? We have 1. So the decimal point comes here. Therefore, the answer is 31.2. And let's see if that's right. I think that is good. Boom. All right. Let's keep it going. All right, next, Eric's dog gets 45.3 grams of protein each meal. How much protein does the dog get in 8 meals? So 1 meal is 45.3, but now we want to know the protein in 8 of those meals. So it's just a multiplication problem, 8 times that. So let's do it. 8 times 8 is 64, carry the 6. 8 times 5 is 40 plus 6, 46, carry the 4. 8 times 4 is 32 plus 4, which is 36. And the decimal goes here, so 366.4. All right, cool. You're asking what is my job? My job, I work in education. I'm a teacher. I'm a private tutor, and I do everything. Hey, I got it wrong. Oh, no. What did I do? Darn it. One of the digits in your answer is wrong. Oh, I wrote the number down wrong. No. That's a 3. 24, that's a 2. 40, 42. 32, 36. So 362. 362.4. Yes, when I lived in Turkey, I worked for Marshall Boya. But anyways, yeah, that's what I do now. I work all in math education, create video materials, video content. I make math music videos. If you check on my Instagram, you can see some of that. Yeah, but exactly. Specializing in math. All right, let's do these mentally. So this is 33.42. 33.42. Let's see if that was pretty good mental math. I just did 6 times 5.57 in my head, and I'm going to be pretty happy. I got it. Yeah. All right, cool. So I'm going to do another. I'm going to try and do this last one in my head too. Let's see if you guys want to try it as well. See if you can beat me. Let's see what we got. All right. 7 times 3.4. That's easy. 21 plus 2.8. 23.8. 23.8. Oops. 23.8. Hey guys, yes, my name is Huzaifa, and my company is called Scalar Learning, and I'm also a teacher and a tutor specializing in math. I have all sorts of education products. And if you're watching this now and you want to see me actually solve the problems, not just hear me talk about them, go to YouTube, search for Scalar Learning, and jump on the live stream that's happening right now. And you can watch me go through the entire pre-algebra curriculum, which is so foundational to the study of mathematics. And you can jump on and watch me go through these problems as opposed to just hearing me talk about them. So I encourage you to do that. I've also got tons of math music videos on my channel, which are, wow, they're really fun. And they're also educational as well. So definitely do that, and let me know what you think. Let me know if you're enjoying this, or let me know if there's anything I can do for the next live stream to make it stronger, better, more engaging, more interesting. Here we go. Whole numbers and integer subtraction problem type 2. So we got 4 minus negative 8. And here we got negative 10 minus negative 5. So now something interesting is happening. When we've got a minus and a minus, okay, these two guys kind of cancel out. Sometimes I write a double plus. Some people kind of combine them and turn it into one big plus sign. The bottom line is these nullify each other, and this just becomes an addition problem. So it's just 4 plus 8, which is 12. Same thing's happening here. These guys nullify each other. And so really this is a negative 10 plus 5. Different teams, therefore this is a subtraction problem. So it's 10 minus 5, which is 5. But the negative side dominates because it's bigger, frankly, in terms of absolute value. So our final answer is negative. So our two answers for these problems are positive 12 and negative 5. Yes, I see that you guys are asking for me to go more slowly. I'll say again, if you go to my YouTube channel, you can see the video. It'll be easier. So again, go to YouTube, search for Scalar Learning, and you can check it out there. It'll be much better. All right, let's keep going. Next. Integer subtraction. Negative 4. This is going to be, I'm going to do this quickly. This is negative 4 plus 8 is 4. 6 plus 3 is 9. Boom. Done. Do I have any questions? No. All right. We just crossed the 1 hour mark, and that's exciting. Next question. Come on, Alex. Why are you so slow? Why do you do this to me? Guys, I may have to end this pretty soon. I just don't get why Alex goes so slowly. It drives me crazy. And if I restart this later in the day, I'll again be able to bang out, blow through these topics much more quickly, and I think it'll be better for everybody watching. So I'm going to finish up this topic, and I think I'm just going to adjourn for now, and I will come back later. Negative 5 plus positive 3 is negative 2. These are my two answers. 9 minus negative 4 is 13, because it's just like 9 plus 4, which is 13. And come on, come on. All right, now I want to see. I'm kind of wondering how many topics I actually got through. I'm going to say 25. That's my guess. Let's actually take a look. So I think I started at 67 today. Oh, wait. So we passed this topic. Brilliant, Huzaifa. Words of encouragement. So cool. Let's take a look. Actually, I don't want to continue my path. I'm going to actually see what we got over here. What did we get? Wow, it is just so slow. I don't get it. Here we go. All right, so where did we get? We're 12. Oh my gosh. Not nearly as far as I thought. Is that possible? Because that means only 8 topics were finished. No way. That can't be right. That can't be right. Yeah, I did 28 topics today. How did it say only 75? Oh, no, that's right. I didn't start at 67. I started at 47. All right, that makes more sense. I was like, what's going on? So I started at 47. I did 28 topics. That's about what I estimated. So, guys, I would love to keep doing this, but again, Alex, it's slowing down. It's glitching. I think it makes more sense to jump off now. I'll come back on later today, I promise, when I have more time, possibly in the evening, and maybe I'll blast through another 25 or 30 topics, and we'll take it from there. Guys on Instagram, thank you so much for joining, and you can, again, check out my YouTube channel. Go to YouTube, search for Scalar Learning, and you can see all my videos, and you can watch the actual video for the live stream. And guys on YouTube, thank you guys so much for joining. Hope this was helpful. Once again, I'm going to keep this going, get you explanations for every topic in the Pre-Algebra Pi. So you'll have everything at your disposal to knock this out on your own. Take it easy and have a great rest of your Saturday.